responsibility for control dependency. Who have the responsibility for controlled dependency? Yeah. Someone is responsible for maintaining controlled redundancy. The first question, is it DBMS? Is DBMS has this responsibility? DBMS should have the capability, yeah, based on our textbook. Our textbook says in this way, DBMS should have the capability to control this redundancy in order to prohibit inconsistencies among the files. The question is, although you say it should, but it cannot do it because it's too complicated. The DBMS is not smart enough to do that. Yeah. So DBMS, there is no way for the DBMS to do that controlled redundancy. That's the work requires high intelligence, very high intelligence, okay, advanced work. Yeah. So should or not, but it cannot. Okay. Yeah. All right. Yeah. What DBMS can do, relatively simple work. Okay. No high intelligence, relatively straightforward, simple type of work. Yeah. Enforce certain constraints. Not now, that's simple. Hey, yeah. Some values equal to some other values, less than, greater than. Check those conditions. That's easy. So DBMS can do easily. Yeah. All right. But DBMS in general cannot enforce business rules directly, because your business rules could be very complicated, right? Yeah. They cannot enforce business rules directly. Okay. Yeah. Even you describe your business rules closely, yeah, very well. Yeah. You need to write your code to do it. Last time I mentioned we can use stored procedure to enforce business rules. But that's our responsibility. We write the programs. We write the stored procedures to enforce business rules. Yeah. Yeah. All right, yeah. So not the DBMS directly, okay? Although your code is running inside DBMS, yeah. But the main effort, you write the code, right? That's the main effort. You need to pay, okay? Yeah. All right. So as a conclusion, that's the responsibility of application programmers. Yeah. Our group, yeah, we position ourselves in this group, application programmers. Yeah. All right. Yeah. All right, so that's the remaining topic in part B. Yeah. So let me jump to quickly, because we spent too much time. So we need to start a new topic quickly. Yeah. Part C. Yeah. Part C, this new topic. Yeah. I try to go a little faster. Yeah. So the thing is, this object-oriented databases, that's not a mainstream databases. This type of databases are rarely used in the business world. So that's why, yeah. So I give you the concept, okay? So I do not need to spend too much time because nobody will use this type of databases. But there is a special type of modification that is used a lot in the real world. So I will talk about that modification, yeah, but not this type directly. Yeah. There is some, some halfway product, okay? Yeah, not this complete idea, half of this idea. That product is very popular in the business world. So I talk about that idea or technique. Actually, that is a technology. I will talk about that technology more in this topic. Okay, all right, yeah. Oh, right. Yeah, yeah. Why C.3? Yeah, we should go to C.1 first. Yeah, all right, yeah. Not C.3. All right. C.1 here. Yeah, database catalog. All right. Catalog, we learned this concept before, right? Yeah. And I think we can go a little faster here. Yeah. Catalog, dictionary. Last time we use a diagram, picture, figure. Yeah. We see the catalog. Okay. Concept of database catalog. It contains metadata of databases. Yeah. So that's the location. We know two separate locations. Yeah. So in that figure, we draw two cylinders, right? Two cylinders. The one cylinder we store metadata, the catalog part. Okay. So that's the descriptive data for our business data. So we call it secondary data. Yeah. So useful information about data in the database, descriptive, yeah, supporting data. Yeah. Otherwise, our business data cannot be organized well, efficiently. Yeah. So we need this secondary descriptive data. All right. It contains structure, constraints, type, and a storage format. Yeah. Yeah. In our next module, module 3, we will learn the details of this structure, constraints, type, and the format. Yeah. In our module 3, we learn this part. Yeah. And this part of data accessed by DBM. Oh, big problem. I forgot to connect my power adapter. Yeah. So I noticed the, dim. So that's, it could shut down quickly. Yeah, it could shut down quickly. Oh, yeah, all right. Brighter, yeah, but still, yeah, need to charge. Yeah. So access by DBMS, not by programmers. We cannot access that part of data, all right? Because we can mess it up. Yeah. If you can access that part of data, you may break the structure. Yeah. So you're not allowed to access that part of data directly. Yeah. So only DBMS knows how to access that part of data in a legal way. Okay. Yeah. All right. So yeah, here DBMS. Yeah. Sometimes you see this term, DBMS catalog. Sometimes you see database catalog. The same thing. Okay. Yeah. No difference. Yeah. Just people call different ways. Yeah. A database about the database object. Now we get to our main topic of part C. What do you mean object-oriented databases? Yeah. Yeah. It's a new type of databases. Objects. Yeah. So the data format, the data you stored in your database as objects directly. So what do you mean objects? Programming objects, right? Yeah. Object-oriented programming language. When you write object-oriented programming programs, such programs, Java, C++, and other object-oriented programs. Yeah. You need to store your data in objects frequently, right? Yeah. So we call it programming objects because we have other type of projects, right? Yeah. Here we're talking about programming projects. It has certain structure, right? Each object you need to define its structure in the class, right? You need to write a class before you can create an object. You need to define class first. That class is the definition, the specific structure of your object. Here, think about your programming objects are stored in the databases directly. That idea. Okay? Yeah. So some researchers, so this why people talk about this idea. Some researchers, they start their research projects. So this is one of their projects. So they propose this idea. So then they do research on it. They try to improve. First, they make argument. What's the benefit of this type of new databases? Yeah. So they need to justify this idea, right? Yeah. So here, oh, sorry. Yeah. So this object already, yeah, I jumped too fast. Here, we still talk about database catalog. Yeah. Yeah. Anyway, yeah. So we will go there quickly. Yeah. Anyway, so here still catalog. The users not allowed to modify details in the catalog directly. Yeah. So let's quickly pass this one. Users can only view tables in it. Yeah. Only DBMs can access it. Yeah. And this is important. This last property. Yeah. No SQL system do not have metadata. Yeah, this is important property. Metadata, descriptor. Yeah. You may ask why. So here I can explain why no SQL system do not have the metadata. Yeah. Metadata is only needed when your data structure is very complicated. The structure of your data is very complicated. So you need some special data to describe the complicated data structure. But for NoSQL, key value pairs, right? The structure, the JSON type data. JSON type, everybody knows the JSON type, right? Yeah, we assume for programmers. All programmers are familiar with the JSON type data structure, right? Yeah. So the NoSQL, we know JSON. That's the format. Yeah. So if you know the format, why you need a metadata to describe data another time, right? JSON format already enough to provide the data description for NoSQL system already. Okay, so for that reason, there is no need to create the metadata inside the NoSQL system. Okay, you can see it's simplified. Yeah, so that part is gone. Yeah, simplified. Okay, yeah. But you can see the drawback part. If you want to put a sophisticated structure in your data, you cannot use NoSQL. Sorry, you go back to use the traditional DBMS. Yeah, that's the right place. You work on the sophisticated structure for your data. Yeah. But only your data can be handled by JSON format. Then it's a good situation to use the NoSQL system. Yeah. All right, so here, just let you know this big difference. Okay, all right. Then C.2 integrated constraints in DBMS. All right. Data integrity issue. Yes. So, yeah. Certain conditions on data must be applied. Certain conditions. Yeah. So, what are those conditions? Yeah. Who will enforce them? Yeah. Application programmers or DBMS, right? Yeah. So, but we need to, get into the details. Some of them relatively simple types of data integrity DBMs can enforce. But those, the harder part related to the business rules, application programmers. Yeah, we'll talk about that. Yeah, but here, yeah, just those things. But here I give you the, details. Yeah. Integrity constraints. There are these types commonly we need to work on. Yeah. Specifying a data type for each data. So integer, string values, floating point, double precision numbers, right? And the number of digits, the number of precisions, all that kind of information you need to specify in your table definition. Yeah. Yeah. So the DBMS can enforce this, right? Simple. Yeah. So this is the DBMS job to enforce it. Second one called referential integrity constraint. Referential. So this is one important concept we will learn. Not here. That's the foreign key concept. Foreign key concept. Yeah. So in our module 3, we will learn foreign key concept. So in one table, you need to refer the primary key of another table. So here you define that key as the foreign key. Yeah. But the detail, we put it in module 3. So we will learn this foreign key concept. Yeah. But this one, DBMS can enforce. Yeah. Easily. Yeah. Simple, easy. Yeah. DBMS can enforce. Yeah. So specifically, here, give you a little more information here. A record in one file. One file means one table. Remember last time I said, so one table is stored physically as one file inside DBMS. So here, one file means one table. A record in one table must be related to records in other files. Yeah. Sometimes we need to do that kind of relationship. Yeah. Yeah. Necessary to do those things. Yeah. So we need this concept. Yeah. Foreign key concept. Yeah. Uniqueness constraint. Yeah. Some of the values for some special columns, we require the values must be unique. That's a constraint. Okay. Yeah. So DBMS can enforce this kind of constraint easily. Yeah. So simple. So we leave it to DBMS. Yeah. And here there is another concept called the key concept. So what's the key concept? Now, so those fields, those database fields that have the unique values, we call the keys. Okay? Yeah. A key field. Yeah. Or let's say a key field. One field, it can be called a key field. All right. So it is a field with unique values. Okay, yeah, that's simple definition. All right, yeah, yeah. So this key concept, yeah, also important. Yeah, also important. Yeah, yeah. And then later, when we learn indexing technology, remember I mentioned that, but I skip it, yeah, because I need to use a video to talk about that. Indexing technique, yeah, indexing technique. Then in that place, this key has a special role to play in that indexing technique. Yeah. Because we need to do with unique keys, we can sort, we can do binary search. Yes, sorting, binary search. Yeah. So in our module 5, we will learn the indexing technique. Yeah. Yeah. All right. Then the last one, business rules. Also, it belongs to the integrity constraints. But this part, because it's too complicated, and a DBMS cannot handle the complexity of the business rules. So we, application programmers, we need to write our code to enforce this type of integrity constraints. Okay, yeah, yeah. All right, so here, give you that idea. All right, so then C.3, store objects in database. Now, I need to talk about how to store objects in databases. Okay, all right, yeah. Yeah, I already mentioned that programming objects. Okay. So you're familiar with programming objects. Okay, yeah. So here the question is, those researchers, here I keep mentioning those researchers, all right? I keep mentioning those database researchers in academia, okay? So not in industry, in academia, yeah. So in their research project, they thought about storing programming objects into databases directly. That idea, yeah. But that idea is not successful in the business world. No. So business people, they don't like this idea. So now nobody uses this type of databases. Yeah. But here I just quickly give you the basic idea. Yeah. So it's a new type of databases. It's called object-oriented databases. Yeah. Yeah. The reason, the justification, they told us, all right, handling complex data structures. You do not need to do data conversion. You just store the object directly into the database. Then when you retrieve, you do not need to do conversion. Yeah. So the object you store as binary data, object is binary format, right? Programming object takes the binary format, not text format. So the binary object is stored in database directly. So you cannot use any tool to view it, right? Binary object, how can you view it? Okay, yeah, yeah. So after you retrieve the binary objects from the databases, you can use in your programs directly, right? So the main benefit they claim, because you do not need to do conversions, data conversions. Yeah. The data that we can view, that's in text format, right? The data in the binary objects, we cannot view. So if you want to do communication with our users, if we want to modify, we want to view, all right, modify. Then a conversion step is needed between these two different formats. Yeah. But here, they want to skip that conversion step. If you skip, then nobody can work on the data directly. Yeah. So that's one thing. All right. So no object relation conversion. Yeah. So you save some work, but the problem not convenient, right? Yeah. No such relation, then people cannot work on the data directly. Yeah, that's the problem. Yeah. So then the conclusion, have not found widespread use. Yeah. Yeah. Here, I think this is, some soft way. What I feel, you can say useless, okay? Only research projects. Yeah. Let's say in this way. Yeah. Only research projects. So no business usage. Yeah. Never used in the business world. Yeah. Or the usage very limited. Okay. It could be ignored. Could be ignored. So little. Could be ignored. Okay. Yeah. All right. But people may ask, if it's useless, why we spend time here? Yeah. So the reason we spend time is on the second half of the topic. This one is very popular in business, this topic. So here I put it, object relation mapping solution. This one, this is a big technology improvement in the business. There is a mapping, ORM. Yeah. So you cannot skip the conversion step. Okay. So you have to build a mapping step into your database tools. Yeah. So it's a tool. It's a tool outside DBMS. Okay. Yeah. This object relation mapping tool, it's an independent tool. Okay. Yeah. Separated software tool. Yeah. It works outside the DBMS. DBMS does not contain this part. Okay. DBMS does not do object relation mapping work. Yeah. All right. So object relation conversion is done by the ORM tool automatically. Okay. Yeah. Yeah. Here, let me give you some information about this ORM mapping. Yeah. Objects, programming objects, right? Yeah. But here, yeah, so the object part. Yeah. Oh, I cannot do the handwriting. Yeah, that's this problem. I need to find a solution. Yeah. Objects. Okay. Yeah. But the objects, we know we don't want to deal with binary objects. Okay. Nobody wants to deal with binary objects. Yeah. So then, how to do the mapping? So this object side, we deal with. Deal with. Yeah. It's very annoying. Yeah. Deal with classes. How about that? Yeah. Yeah. I just classes. Horrible. Yeah. So here, the one of the famous tool of this type, it's called Hibernate. Java framework. Yeah. It's pretty old. Yeah. But here I just use as an example. It's called a Hibernate ORM tool. Yeah. But we do not work on objects. We work on classes, the class definition directly. Okay, that's text, right? Class. So that's text. Yeah. So we do conversion. We do text to text conversion. We never do binary to text conversion. Okay. Yeah. So we do text to text conversion. So the Hibernate does that translation conversion. Okay. So you start with the text file. Okay. The class file, text file. Yeah. So when you apply the Hibernate mapping tool, it generates different types of another text file, yeah, but do the automatic generation from your beginning, the class files. Yeah, yeah, here, yeah, and yeah, here ORM solution. Change the object relation mapping approach. Yeah. Drop. Yeah. So here, this the key consideration in the OODB, their main feature, their most important feature is drop it here. The most important feature there, no object relation conversion. That one is drop it. Because the drawback is too big. Too big. You know, nobody likes this drawback. Yeah, so it's drop it. Yeah. And the drop manual object relation conversion. Yeah. Yeah. Also, so RDBMS manual object relation conversion. Yeah. So that way. Also, people don't like it. Yeah. Adopt automatic object relation conversion. Object, automatic object relation conversion. But the object here in this place, you need to understand the class definition of the object. People still call object. People do not call class. People do not call class relation conversion. People still call object relation conversion, but it's not a binary object. It's the class definition for those objects. Yeah. Yeah. All right. So the ORM to Hibernate. Here, yeah. Actually, I like to show you example using Hibernate to do the mapping. The tool is automatic. Yeah, I like to give you, description how to use the Hibernate tool to do the mapping. Yeah. Because later you have a chance, not necessarily use Hibernate. Hibernate is just one of the mapping tools. There are multiple other tools. Yeah. In the new Java technology, there are many ORM mapping rely on annotations, annotation mapping. Yeah. So when you define your Java classes, you do annotations. Okay. Yeah. So several places. When you want to do mapping, you do annotations on certain lines. Then you run the ORM tool. Then the ORM tool will use the annotations you put in your code to generate the mapping files. So that's the new way. The old way, you do not do annotations. Yeah. So you just write, the definition files, directly. Yeah. All right. So I hope I can find a chance to explain. Yeah, because this experience also useful. Yeah. Yeah, but one video for Google search engine, yeah, because that one I need to explain the social media data and the traditional data. So that's an important topic for your understanding. Yeah. So this ORM tool, I may delay a little bit. Yeah, if later I have some time after midterm. Yeah, let's say after midterm, if it's possible, I can show you. Yeah, I can create a video. Yeah, so when I come to the meeting, I can. I have an idea. So here one problem. I do annotation so slow. Yeah, so I probably after midterm. Yeah, let's say after midterm. So I may record some at home. I record a 10-something minutes video to explain some concepts. Yeah. So like ORM tool, how to run, right? So I record a video. So here I play that video. After that, then I talk to the lecturers. Hopefully, because I shortened my presentation a little bit. So hopefully this writing annotation